looks like a fun equation here. This has some radicals in it. One thing to notice with radicals is you must check answers. I don't know how that happened. Must check answers. There's always a chance you get what are called extraneous solutions. So at the end, once we finish this problem, we're going to go back and make sure that our answer actually works. Okay, so radical of 5v plus 2 equals radical of 3v plus 14. Let's take both sides and square them. The reason I'm squaring is because a radical is canceled out by squaring. So on the left-hand side, we'll get 5v plus 2. And on the right-hand side, we'll get 3v plus 14. Okay, as far as collecting like terms, let's subtract 2v from both sides and then subtract 2 from both sides. So with the cancellation, minus a 3v, sorry, not a 2v, minus 3v from both sides, so those get cancellations. Then we will get 5v minus 3v, which is 2v. 14 minus 2, which is 12. And so dividing by 2 yields v equals 6. Are we done? No, we must check answers. So if I go back to the original problem, on the left-hand side we have a radical of a 5 times a v plus 2. And on the right we have a radical of a 3 times a v plus a 14. So if I go and I replace with our supposed solution, put the 6 in there, on the left-hand side we have 5 times 6 is 30 plus 2, so that would be a radical, 32. And on the right-hand side we have 3 times 6, which is 18. 18 plus 14 is also 32. So this is a check, and that means that yes, indeed, v equals 6 is the solution. Okay, so why don't you pause the video for a second and try this one. Okay, assuming you paused the video and tried it out on your own, now let's try to do it together. I put a little bit of an extra wrinkle here because notice that I put everything on the left-hand, the two radicals on the left-hand side. So if you tried to square, it's not going to cancel how you wish. What you really need to do here in order to be able to do it correctly is you have to add one radical to both sides of the equation so that you have radical of 3v plus 14 on the left and the other radical, which is v plus 6, on the right. We need it to look like this so that way when we square both sides the radicals will cancel and we don't have to worry about foiling. If we had done it in the first step, we would have some kind of multiplications in the middle that overcomplicate things. So now let's take the red pen and square both sides so that we have on the left 3v plus 14 and on the right v plus 6. Subtract v and then also subtract 14 and we'll get 2v equals, let's see, 6 minus 14 is negative 8. And so now when we divide, we're going to get v equals negative 4. Done? Hopefully you said no. Let's go back and check and make sure this solution actually works. Negative numbers make me a little suspicious, right? So if we were to plug it in, we would be getting radical of 3v plus 14 equals radical 3 times negative 4 plus 14, which is radical negative 12 plus 14, also known as radical 2. If I plug it into the other radical, the radical of v plus 6, we get the radical of negative 4 plus 6, which is also the radical of 2. So now we'd have a radical 2 minus a radical 2, and that does give me 0. So therefore, the final answer to this is indeed v equals negative 4.